Good morning, Sharon.
Good morning. Good morning, sir.
Seems others are still not in there. Shall we start the
Uh,
session?
yeah, okay. No worries.
All right. So today we are going to discuss the module 5 applications, programming languages and translations. Basically, up to module 4, you have mainly focus on CPU and related stuff, how these CPU related work, like simply the processor fundamentals was gone. So now onwards, we are going to discuss more practical aspects and how these things are involved in real world. So that's the main focus from now onwards. So today we are starting with the programming aspects, especially how it works in a computer system. That's the main focus for today. And today I'm going to deliver some of content, but that's not covering all the information covered by Dr. Ganesh. I would strongly encourage to everyone to go through all the video sessions recorded by Dr. Ganesh and get some external get some knowledge that you need. Further, it's really important to go through some additional resources to get or grasp maximum knowledge under this context. So we are going to discuss today some of important things, how the binary code, assembly languages, and high-level languages are related, and how they are used in programming. So, as you already know, we are not much work with these assembly languages at the moment, but we always focus on a programming language whenever we got a problem because it's much familiar for us. And in the other hand, though it's much familiar for us, it's not covering the all aspects that computer can understand. So we need to understand how this connection in between a human understand and the computer understanding is going on, how these translations are going on. So that's the major aspect that we are going to discuss today. And the module scope covers up to a limited constraints. Those are the level of programming languages. Basically, I'm going to discuss high level programming languages, low level programming languages, and how these translations work. Then control structures in programming, basically some fundamental things such as conditional things like if else and loops. Uh, Further, I'm going to discuss some of constructs, like especially the stacks are the main focus for today because as you already know, the stack point is one of key component that we need to understand. So to understand that concept, we are focusing on these stacks. Further, some of tools to convert this machine code, simply how these things are working and how these linkers are working, how these assemblers are working, how the compilers are working, transpilers, and so on and so forth. So the today agenda would cover some of high level discussions, especially the software categorization. At the beginning, I think you know about this. What is this software categorization? How the instructions are, what are these instructions and how these instructions are working. At the moment, you have some understanding. What's a program? Basically, you know up to some extent, and we are mainly focused on high-level programming and low-level programming languages. Then some of translators, especially assemblers, compilers, interpreters, and transpilers. I have given an additional component transpiler, which is not in our scope, but that is really good to understand, especially if you are working in, you will be working in industry. You need to translate most of the things, especially from historical things or legacy codes to newer codes. In that case, you need the transpiler to perform many operations, but I'm not heavily focused on this, but I just give in very high level. Some of programming constructs such as conditions, looping, and stacks. Finally, I'm going to discuss linker, how this linkage works and how computer works, how these modules are connected with each other. That's the major aspect that I'm focusing on today. And the prerequisite for this module to understand, for a better understanding, you should complete the learning materials in the course page before you joining. I'm pretty sure you have gone through as much as, because I have enabled few last week probably I have enabled it. So I'm pretty sure last week you have gone through the materials, extra learning materials and so on and so forth. So you are much familiar with that aspect too. And one important thing is you feel free to stop me any given time. You can switch on your mic and ask any question. Probably I don't think you need to wait by raising your hand, because I'm not in a screen that every time to check whether students do have questions or not. So my kind of request is to switch on your mic and interrupt me and ask any question. I'm really happy to help you. I'm really happy to give answer as much as I can. And in the other hand, for the latter part, I'm going to like latter part in the sense like halfway at least, like some of students are joined still. We have only 2 students. Some of students are joined. I'm going to form the groups for the assignment. I'm pretty sure you have gone through the the questions in the course page. Dr. Ganesh requested me to create to help you to create all of these groups. So I would strongly encourage everyone to join today's session, unless it might be bit late once you start the work, because next week we don't have the entire next week we are in a free movement, so we don't have anything to do. So you can form your groups and have discussions during the next week. Then probably Jan first week, you can finalize your most of the part agreements, what you do, and in a half a way you can complete. So I would strongly encourage, could you please your message if you have Telegram groups or message WhatsApp groups or any other things, then others could be able to join. If not, it might be a big hectic task for everyone. If there's no groups are formed. Right. So the software categorization, as you already aware, basically application softwares and operating systems are the major divisions for the softwares. So if I give like a high level, an operating system is a like it's a system, like it's a computer program that controls hardware and software in the system. So mainly operating system performs this controlling part, managing some resources and so on and so forth. Operating system is the major component that you need to understand, but to work on this operating system, I mean, to get the fruitful output, we need to use many of the application softwares. So it might be simply starts from a micro word processor, or it might be a complex programming IDE or any other thing that fit for your case. It might be a browser like Google Chrome, or it might be a graphical editor like Photoshop. There might be a lot of vendors for this photo editing and so on and so forth. So any kind of software might be an application software. So simply an application software is focused on to give a specific task. As an example, if we take Microsoft Word, there's a specific objective. The objective is to writing something. That's the main objective. But apart from that, there might be some minor or mini objectives here and there for many applications. If, as an example, if we take a web browser, the major objective of a web browser is to search something from through internet, through what we call these networking protocols, right? But if we take a browser, we can do simple calculations. Like if you want use as a calculator, we can use as a calculator. If you want use as a translator, we can use a language translator. I mean, you can use to translate different languages like Japanese to English or something. So that's why I told there might be the software might be mainly focused on a specific thing, right? But there might be some additional objectives also. That's the main consideration that you need to understand under this context. Now, the software was developed using programming languages and stuff, because last few weeks I have discussed the same thing again and again. Again and again, I'm telling the same thing. A human can understand natural language like English language, Sinhala, Tamil, Japanese, or any other language. A human can understand. Yeah, we can understand this kind of a thing, but it's not understandable through the processor. Processor can understand only ones and zeros, simply the bits, the transfer to the processor. Now, our ultimate objective should be, we have to provide instructions, we have to provide information, we have to give the relevant data to the processor, what you need to do, but we can't provide instructions simply like ones and zeros. It's a big task if we perform this kind of operation. So you can understand this. Sorry, any questions? Any questions? All right. If we should understand there's a big gap in between the human and a computer. So our ultimate task is to make sure there's a linkage in between these two, because we want to get some work from the computer, and we need to make it our life easier. So we need to understand, all right, we have to give proper instructions in simpler manner in a given natural language. It might be English or any other language that fit for the case. Then we need to convert into a machine understandable format. Simply you have to convert into bits like ones and zeros. That's the major problem. Now we are trying to solve this problem a bit by bit. Then we could able to realize how to get the most work done. Right now, as I told, the processor can understand only the binaries. We don't understand binaries. We can understand, but it's a big task. As an example, we can convert what is this value, and we can map it. That's not a big deal for a one or two words or letters, but think for a paragraph, for a big instruction set of instructions. So it might be taking sensor input from some IoT device. So it's a big deal at that time. So we can't perform all of these operations. We can't take one by one, and we can't add those things into our context. So we need to understand there's a gap. So we are trying to solve this gap. I mean, we are trying to understand how this computer scientists world, the computer scientists were resolve this problem, how they took the process to solve this problem. Basically, initial implementation was instructions. So I think you have good understanding about instructions. We have heavily discussed last few weeks what is this instruction, STAs and stuff. But today also we are going to discuss a bit further. And in simple terms, it's a binary code interpreted by the CPU to perform an action. So an instruction is something that interpreted by the processor. So simply, if we take, I have given the same example few weeks back, probably week 1 or 2, I have done in class, like stand up, sit down. So these are the instructions that I have given for a human. Those are the instructions that I have given for the human. So human understood it, yeah, well, but somehow our objective is to understand the same instruction to the computer too. So that's the root cause that we need to understand. All right, we have to provide sufficient instructions, clear, detailed instructions, how to do some specific task. As an example, it might be just a mouse movement from one location to another location. It might be the case. So we can take these XY coordinates. We can take XY coordinates and we can instruct the computer. All right, you just take all of these information, how these coordinators words change during. So each and every movement in a computer, in a computer, or every single activity in a computer, there's a specific set of instructions are given to the computer what to do. You need to understand the very first thing is we have to provide instructions. In simple terms, instructions are binary codes that interpreted by the CPU to perform specific tasks. It might be load some information, it might be store something, it might be move something, and many other things, many other forms might be there. There might be thousands of things that we have to dealt once we are working with instructions. But I'm not going to too detailed on the same context, but I'm going to simplify the entire process, how these instructions work and how these instructions are going to helpful for us. I mean, I'm not going to focus on these instructions or the instruction set architectures or any other thing, but the higher level of things like programming would support you for these instructions. That's the major consideration for me. And if we take all of these instructions, you could be able to understand, all right, it can simply state it's as a program. It's a program simply. That's the main focus. So if we have thousands of instructions, then we can compile it into one component, which is known as a program. Now, I think you got the entire story, what was happening here and there. In simple terms, instruction is a binary code interpreted by the CPU to perform an action. Yeah, we got it. A program is a series of instructions like this in binary that processor can read and interpret. So these instructions should be read and interpreted by the processor. So that's the key consideration that we need to focus on. So whenever there's set of instructions, we have to let the processor to understand if these instructions are mismatched, if these instructions gone wrong, the processor would perform something that we are not expected. That's the root cause we need to understand. We need to understand carefully. The instructions are quite important because the instructions are the commands that we issue to the processor to perform some operation. That's the key consideration that we need to do. The processor cannot read and interpret. So processor should be read it and processor should be interpreted. So our ultimate objective is to create set of instructions that understandable by the processor. Any questions up to now? All right. Now, in simple terms, what's a program? It's just a set of instructions. Now we got it. All right. This is a simple thing. A program is just a set of instructions. Yeah, we got it. Now, what is a programming language? Now we know what's a program. What's a program? It's a set of instructions. But how we can issue these set of instructions to a computer? For that, we have to use a programming language. Why we have to use a programming language? Because we can't give instructions in binary code, ones and zeros, simply. So we need to use a programming language. These programming languages are much familiar for us. It's really, really easy to understand for us. It's just simple English text, or it might be some languages supported for many languages like Russian languages, Spanish, Japanese, like different languages supporting. Like I'm not exactly categorizing what are the languages they're supporting, but mostly like nearly 99.99% of languages supported for English language. So simply most of the like nearly, I think majority of the world, like de facto English is the like common language, right? So everyone can understand, nearly like everyone can understand what needs to do. So that's why we all learning these programming languages in English, but it's not the only approach. Or we can, like as an example, if we take a command like in Python print, there's a Japanese command also. Similarly, there might be some another language implementations also, but for the most part, since we don't have single implementation, we have to use or Tamil implementation, if I'm not mistaken. none of languages do support for both languages. We have to go through English, but somehow it's in a natural language. All you need to understand is a programming language is a set of instructions that providing to take the stuff into our case, right? Using a plain language, a natural language. But these languages are specified to perform an operation. That's the case. It's not just a word processing like simple essay, but there's a logical sequence of activities to perform. So that's the difference in between the normal a text or a paragraph or an essay and a programming language. So the programming languages do have programs and there are specific keywords to perform different operations. If we take Python or Java or C# or whatever the language, there are different aspects, different key terms or reserved words. Sometimes you have learned all of these things, reserved words. So that means there's a specific sequence of things that we have to do. As an example, if we take Java, we have if, else, break, while, do, while, int, boolean, char, then double, float, right, class, lot of things are there, right? Extends, right, then implements, right? So a lot of keywords are there. These are reserved words that we have to use. So programming language, once we implemented something using a programming language, simply we could able to understand, all right, these are the instructions that focused on to perform a specific operation. As an example, today in the latter part, we are going to discuss simple conditional things like if. Now, if we take this condition, this is a simple Java operation, we'll assume x is greater than 0. So by having this small code snippet, we instructed to the computer, okay, in any case, I have defined an integer variable called x. I'm really sorry if you are not much familiar with programming, but don't bother. It's just a variable, right? I'm pretty sure you know up to some extent. This is a variable called x, and I have assigned the number 10, the value 10 for x. Then I'm going to check whether x is greater than 0 or not. In this case, this is true because 10 is greater than 0. 10 is greater than 0. So it comes to this scope and it works inside this scope. In any case, if it is minus 10, the program is false. The logic is false because now minus 10 is not greater than, it's smaller than 0. So this if condition would not work and it comes to this place and start executing the rest of the code. Now you have to understand the range of this case. It's just a one simple operation that we have given greater than 0. But for x, there might be a huge range. It might be from minus, I don't know, we'll take minus infinity, a big value, to a plus infinity, a big value. But I'm agreed, whatever the stuff that you have defined the data type like integer, double and stuff, there are limitations. Yeah, I agreed with you, but I just given very high level. There might be a range of values can store in this value x. So that's the main chaos or main root cause that you need to understand. All right, a programming language is very important because it can give a wide variety of sequences for us, wide variety of things for us to use. And in the other hand, it's much familiar for human. Think if. This is a simple English term, isn't it? It's just if. And this is a shortened form of integer. So it's a shortened form of integer. So we can understand easily. And this is x, this is 10. All of these are much familiar for us. So programming languages are supporting for us to solve the big problem. That means communicating with the processor. I think you got the overall idea of what is a programming language and how this programming language is working and why we need these kind of programming languages. So a bit more detailed, like again, I'm going to discuss some of the things. It's a method that we can provide instructions to the computer. So basically, programming languages are using. It's a kind of a method. It's a kind of a method to provide instructions to the computer, but much familiar for us. That's the case. That's the case. That's much familiar for us, but it's much easier to give the instructions for the processor. Anyone to have any experience in any programming language, any language? That's language is not a matter for us. Any of you do have any experience? Java, Python, R, Ruby, C Sharp, any programming language? Python, good. Any other? Any others?
Java,
Java, very good.
Ruby, C++.
Oh, nice. Great. How about the others? Thanks, Shan. You got important things. I can remember you have told Bash and stuff. Yeah, thanks. How about any others? Do you have? If not, I would strongly encourage guys, if you are doing software engineering, even security guys, you have to work with programming a lot in future. So I would strongly encourage you to understand and go through some of programming because, yeah, if not, it might be too late trying to work on your work. Right. Now, in simple terms, programming language is something that we can provide instruction. It's just a methodology that we can use, right? And there are thousands of, I'm not sure, not thousands of, hundreds of languages might be there. I'm not sure how many languages are there, but if you research it, we can find. But I'm pretty sure more than 50 languages are in the world. I'm pretty sure because almost some of trendy languages also there, like Python are there. So languages are changing time to time. As an example, time back, if it is take around 2007 around, Java and C Sharp is the foremost languages, dominant languages in industry. But after a while, changed to different things, and nowadays everyone like the trending terms are R and Python. So yeah, that's the nature based on the business requirements are changing. So the programming are changing. So the business models are changing. Human objectives are changing and the business requirements, the human requirements, everything is changing. So the programming language should be changed according to these requirements. There are thousands of root causes, thousands of reasons might be coming to the context. Sometimes it might be like thousands of packages, or it might be fit for the case, or it might be easy to use, right? So different cases might be there. As an example, if we take for Python and R, we can train Python R or MATLAB. We can use these three things like to train a neural network. Yeah, but for MATLAB, you need to have a license, or else you might have to go through some additional steps. You might be a student or something. But once it comes to R or Python, you don't have these kinds of restrictions. You can do it. So that's why I'm telling, like, it depends on many cases. It depends on many cases. I just gone through some additional information for you to understand, for better understanding. It's kind of a bit of out of scope. And there are a lot of programming languages available. Programming languages can be broadly divided into two main parts, high-level languages and low-level languages. But I have seen in many places, apart from this categorization, there are different definitions, different categorizations are there. It's arguable. Yeah, I agree with you. You can research and you can discuss what could be the proper definition, but in very high level, I have divided into two, which is like the norm of the programming context. So the high level and low level, but there are middle level and different programming languages have divided by different people. As you know, like after a while, there are different concepts are growing. So different different people interpreted in different aspects. So that's the natural situation. While after subject is growing well, different people explain different things. as per they realized, or it might be based on the majority realized, and there might be minority realized something else that could be happened, because this word is quite complex. So I'm not going to discuss further about this, but I would agree if anyone do have any other implementation interpretations, rather high level and low level. If you have sufficient evidences, I'm okay with your aspects. I'm okay with your the stuff you are work on through, right? Any questions up to now? No questions. All right. So we'll go through a bit of low-level programming languages at the beginning. A low-level language is one that is extremely similar to the writing machine instructions and offer little to no abstraction of programming ideas. So we mainly focus on a low-level programming languages, means it's much familiar to the processor. And some of examples are assemblies and machine code. So you could able to understand, oh my God, it's like I'm trying to give my full attention for a processor. In general terms, these are processor specific languages. There might be like, it's kind of a simple thing to memorize. Right. It's processor specific languages. Mainly these are processor specific languages providing help for us. So you need to understand these are processor specific languages. Yeah, might be some differences, right? I would agree again because this is a very broader topic. I have narrowed down up to some extent, but it's sometimes it might be a big differences of like what we call some confusions might be there. I agreed with you because, you know, as I told, after a while, after abroad, some of people interpreted in different manner. So we have to agree if it is with sufficient evidences. Right. So assemblies and machine codes. Shall we do a small work? I feel it's like half an hour we have probably. Yeah. So I think it's kind of a sleepy moment after half an hour. It's obvious since it's online. No, don't worry. Shall we do a small work, individual work? Give me one assembly language that you can find, and a name of an assembly language or an implementation of assembly. Or else it might be machine code. You can, I just want to check whether you can interpret what's the assembly language or a machine code. You can use the chat and you can share the answer with me, or else you can switch on your mic and you can answer.
So can you please repeat the question?
Maybe the question is, I have given two examples like low-level languages are assembly and machine code. Can you find a name for assembly language? Can you find a name, a programming language or kind of something? Is there any possibility? I just want to check. Check whether is there a assembly language. Is there something like that or not? Assembly machine code or not? A name. As an example, Java, Python, C, it's not the answer, right? Is there assembly language kind of thing that you can find? I will give a couple of minutes. You can quickly search and share the answer in the chat. If you want to switch on your microphone and you can answer it, now it is at all. 2 minutes, quickly search it. And I would highly appreciate everyone's engagement, unless it might be sleepy. environment might be there. So to avoid all of these things, I'm doing these strategical things to make you big. So I will give 2 minutes, quickly find it and share the answer. All right, I got some answers. Yeah, well, I think, yeah, some of architectures are given. These are not variables. No, probably you haven't found anything. I have a bad example to give, right? It's not a perfect answer, but let me share you chat. Let's check this kind of bad example. And
So isn't ARM is a processor set of strong instructions?
yeah, it's that's why I told low-level languages are specifically for processor. So once it comes to ARM processor, we have a programming. If you just search ARM programming, you could able to find a processor specific. It's kind of assembly language, right? It's kind of assembly language, so you can able to understand. That's why I just told it's kind of a bad example, but it's something reality that you can realize. If someone asks, you can search it and you can learn this ARM programming. Even if I'm not mistaken, there are videos also in YouTube and stuff to learn end to end. Right. So these are
Okay,
like.
sir. Okay. Thank you.
You got it, right? So these are like low level. These are like giving the instructions, machine code related stuff directly via telling. But you know, it's assembly, right? It's assembly. It's provide again a similar kind of thing, right? It's a assembly. If you take assembly language, an example would be there. That's why I just told. Sometimes it might be a bit confusion. What is that? That's why I told. I'm always using this kind of word. It's not, I can't give 100 out of 100 because there are some variations in there. So you need to understand assembly languages are like these kinds of things. As an example, ARM. It provides easy for us, and there are a lot of tutorials and stuff to understand how these assemblies are working. If you are really interested, I would strongly encourage you to go through these tutorials and stuff to check what happens in here and there, and even you can test it in a virtual environment. That's the importance. As an example, if we take now our latest processors like Intel processors, it might be a bit hard to tackle on that, but and it's really hard to experiment on that. But if we have assemblies kind of things like ARM, we can perform operations, we can check, we can simulate what happens in here and there. That's why I just emphasize few times the same thing again and again to get some understanding to yourself. Any questions? Thanks. Shehan found that Apple Silicon chips are based on ARM architecture. So that's interesting point added for everyone. So thanks, Shehan, for your input. You know, that's why I told there are a lot of variations might be there. Even I don't know that point. Right. Any other things to add, discuss, or any other things to elaborate? Don't think this is a like online class. Think like a physical class that we are doing in usual method, right? There's no major difference in that physical and online. Only the difference is where we are located, and the other things are extracting. There's no difference at all. You can ask any question. You can anyone. Right. We'll go to the next one. Yeah. Now, once we are working with this in class, sorry, this was time back, don't worry. So you don't want to do this in class activity. Time back, we have done this as an in class activity, but today I have given something else as in class activity. I'm reusing the same slide, sorry, right? This was created time back, and I'm reusing the same thing again. That's why it's in class activity. So somehow issues related to low level programming languages. Now, at a glance, you could be able to understand, okay, it's much familiar for machine, not for the human. At a glance, you should be able to understand, or yes, there's a much towards a specific processor. much towards to a specific processor. There's no ubiquitous or common methodology or common tactic for everything. And assembly is like machine code. So all of these are mainly focused on a specific processor. That means processor specific architecture or specific things are there. So these are the major issues if we dealt with low-level programming languages. As an example, if you learn ARM programming, you can't apply for everything. You have to have for that architecture only, that design only, that assemblers only, that processes only. You can't apply for everything. That's not fit. That's not fit, especially once it comes to a business environment. We can't find a specific processor to be control everything, to be work on everywhere. So we need to get out from these low level languages and we need to take into the next level. That is the high level programming languages. So what we need to do is we need to dealt our work. We need to deal the stuff in easier manner. Then let the computer do the heavy work. So to perform this operation, we have to use high level languages. That's the major consideration under this context. Now, what is a high level programming language and how these high level programming languages are working? There are thousands of, sorry, not thousands, there might be hundreds of, more than 50, I'm pretty sure, programming languages, high level programming languages are there. All of these high level languages are, in contrast to the lower level programming languages, we can initially see it's platform independent. That means if we use a high level programming language, we don't want to specify for a processor, right? And we don't want to specifically understand how it works. As an example, if you have wrote a Python program, if you have wrote what we call Java program, right? Whatever, we don't want to bother. We don't want to worry about that, right? We just want to work on some of language syntaxes, that's it, right? So again, a small icebreaker, shall we see, can you search in internet a list of high level programming languages and share it in the chat? You can take around 2 minutes. These are just small icebreakers. Just search examples for high level programming languages. Everyone could share around 3, but the condition is if one is given the answer, next one can't give the answer. So early bird catches the worm. Start. All right. I can only few of names in the chat. How about the others? I can see Shihan and Zajini. Again, Shihan, Ahmed, and Shihan, Dinuka, Sasini. There are few of other students. I hope people hang on or don't be leave by just switch login. So hang on, right? We'll go this journey together. So I would strongly encourage you to engage these activities. Uh, so it's really good for you guys. That's the thing that I want to tell you. Right. Somehow we'll come to the discussion again. There might be a range of high-level languages like C, Java, Python, and you have developed some programs using Python. I'm pretty sure most of you used at least one or many languages to develop an application. So my question is, once you are developing an application, think we don't want to go too beyond. You just think about a print statement, system.out.println in Java or console.log or print, right? Anything, any statement. It's just give an output for us. Do we thought about the processor that we are working on? Any of you? Not really. What you have done, you just downloaded Python or any other language. Then you have downloaded an IDE. Then what you have done, you just wrote some statement and you have executed it. Boom, everything in your screen. That's it. You haven't thought anything. You haven't thought how the translations was work, how it goes to the processor. You haven't thought anything. What's my processor? Is that Intel or any other processor? What's the environment that I'm going to use? Nothing. You haven't thought anything. You haven't. You just downloaded and worked it. That's the reality. Why all of you have used a high-level language? That means the high-level language is providing very sophisticated environment for us to work on any environment. That means platform independent work for us to perform many things. We don't want to bother about the architecture. We don't want to bother about the operating system. We don't want to bother about how it works. All we need to do is work, get the work done. In high level, these are processor independent languages. These are processor independent languages in high level. That means we don't want to bother about the processor, how it works. We don't want to bother about. Now we know, all right, if it is a high level programming language, we don't want to bother at all. We just want to work on it. But my question is, can a high level language directly dealt with the processor? As an example, if we take Java, you have written in programming language in English, class A, public static void main string args, then you have defined system.printout, print system.out.println, then you have printed some statement with this curly brackets. Can this English language text could be processed by the processor? As per now, you already know, because I have deeply discussed last 3 weeks, how the processor works with ones and zeros. Yes, so memory allocation, how it works and so stuff. My question is, how to convert this high-level programming to low-level programming?
Using interpreters, compilers.
Perfect. Who's that? Good. Right. So we have to deal with different aspects right? We have the different aspects of translation programs. We want to translate it. So that's the key thing that we need to focus on, right? So programs are written in high level programming languages needs to be translated into binaries. We need to translate into binaries. How? By assemblers, compilers, and many other aspects. We want to perform a translation process. Now, we come to the aspect of this translation process using the language translators. So we have completed in very high level discussion related to high level programming languages and low level programming languages. And you know what happens in high level programming languages, and you know what happens in low level languages, and the role of all of these things, right? I will give a couple of minutes to ask any questions that you have.
Excuse me, sir.
Yes, please.
So what is the reason that ARM use reduce instruction set? When I was reading about ARM, it said that it is using a reduce instruction set rather than, I think, the compared to Intel, I think they are using a reduced instruction. So what is the advantage of using reduced instruction set? I think it's called the RISC.
Yeah. Once it comes to this architectures, we have CIRS and RISC, if I'm not mistaken. Some instruction sets, instruction providing architectures are there, but I'm not pretty sure why. And I can't give an exact answer for this for your question. I'm really sorry because I haven't researched on that. But I would think, if I'm not mistaken, that might be much hardware friendly and it might be easy to process, but I'm not sure. I'm not pretty sure. I have to research it and I have to come up with an answer why. Right, I can't give extract yes or no, and I can't give the extract same, but the architectural wise, that's the root cause.
Okay, so no worries. Thank you.
Any other questions? Right, now we'll go to the next part of this discussion, that is language translators. Before we are going to the language translators, I'm pretty sure we have 1, 2, 3, 4, 5, 6, 7 students, right? 6, 7 students are there. Shall we create the groups before going, or else shall we create the groups at the last? What do you want? What's your preferred method? Shall we do it in the latter part, like around 11, 15 around? Or else shall we create the groups now? What do you prefer?
The groups for today's session or the group assignment?
For the group assignment,
We already created, right?
but it's unofficial. We have to create it official groups, and we have to share that information among other, like Dr. Ganesh and management too.
We have a man missing today, sir. What do we do?
Sorry?
There's a student missing today from the.
Yeah, that's the case. That's the case. Some of students are missing. We have only 6, 7 students. Is there any possibility to get them into today class, or else shall we keep empty cells to decide them to join to a team, or what we can do?
So we can just assign them, sir.
Will assign. Shall we complete that activity quicker rather than going to the
Yeah, sure. No worries.
nowadays? All right, what I'm going to do, I'm going to share a document. Give me a second. I want to create a document. Then you can add your name and the give me a second. I will quickly create one shared sheet with you. Then you can add your group number and the name and the students that you like. This is not getting hours, it's just few minutes of work. So we'll complete it quicker. Group assignment. Can you add your name and team number 1, 2, 3, 4, 5, 6, and 7, whatever you. Maximum 3 students in a group. That's the share. That's the condition. Jesus. Right. I have shared an email to here. Kindly add your your I have dropped an email. Just check whether you have access. I have given access for everyone. Quickly check.
I didn't receive it yet. So I have a question regarding how many students are in the class, like totally.
Three students in a group.
No, so totally in the class we have one, I think 2 less students.
I think altogether we have 13 students, 12 students altogether. 12 or 13, if I'm not mistaken. One left in the sense one didn't attend for the lectures. So I think that student, there was some issue with that student, some attendance or something, I'm not sure. I think altogether 12 or 13.
Maximum 3 students
3
in a group.
students in a group. Yeah, maximum 3 students in a group. So simply the group should be consist of 2 or 3. You feel free to decide the group that you are working on. You can add your name and a team number that preferred by yourself.
So 5 is too much in a group. Like it can't happen.
Not 5, 3 maximum. quickly do. Will take around 5 minutes to complete this task. After 5 minutes, I'm going to start the discussion, and you feel free to ask your friends to add their names and the team numbers that they fit. If you have other information, like if you know that they like to join with you, if it is perfectly known and it's approved by themselves, you feel free to add their details also to this document. So don't take more than 5 minutes. I'm going to start the discussion after 5 minutes.
So we should just add the names, right? No need the student number and email and stuff, right? So
What that?
sir. 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 Excuse me, sir. Sir. So are you there? There.
All right. So if you are still not in a mood to add your name, I got group 5, 6, and 2.
So I have a
Yeah,
question, sir.
yeah, please.
So should we add the student's ID and email and stuff, or just the team number?
No, just name and the team number is more than enough because we have very small cohort. It's not a large class, so we know by name, right? So we don't want to bother a lot.
Thank you, sir.
And I can see 5, 6, 2, and 4 is added. How many students added? Together, 11 students are there. I think that's all, if I'm not mistaken. And your team numbers might be changed because we have to add 1, 2, 3, 4 and stuff, right? Based on that, I would change the team numbers finally, right? But there's no major effect on the team number, just to get identify who are the cluster. That's it, right? Right. Thanks for the engagement. I think I will recheck again, and if there's 1 or 2 students are missing, I will add them accordingly for this sheet. Right, thanks to do this work. So we will go to our discussion again, the language translators. So let me share my screen. Right, language translators. This is the second topic that mainly we are discussing today, which are the translation process of the entire situation. So once it comes to the language translators, we have mainly 3 things. Those are the assemblers, compilers, and interpreters. Apart from that, there might be some minor implementations and there might be some other categorizations also that I have seen in different places, but it's again arguable. And if you have sufficient evidences for those categorizations, yeah, you can go ahead, but it should be covered covered by sufficient references, sufficient information. But broadly, vast majority agreed for these translators, language translators, as assemblers, compilers, and interpreters. We'll go through one by one, then we will understand what happens in here and there. So first of all, what's anything got? Can you hear me, guys?
So now we can, sir. We missed you after.
Can you hear me, please?
Yes, sir.
Can you hear me, please?
So we can hear you, sir.
Yeah, so we can hear you.
Guys, can you hear me? We can.
Yes,
All right.
sir.
All right. Thanks. All right. I just want to check whether you can hear because I got some interruptions. Right. Now, what is a language translator? We'll take a simple example and we'll go through what happens in here and there. Now we'll get an example. This is a Japanese. I don't know. This is Japanese, Chinese, or some another text, right? We'll assume that's a language. We'll assume that is Japanese. And this Japanese guy met a Sinhala person who is speaking natively in Sinhala, do not have any understanding with Japanese language. How to exchange the knowledge or how to communicate with a Japanese guy and a Sinhala guy? because Japanese guy, no single at all, no understanding of what is single at all, no singular word, even no singular word, right? No singular, no singular text. Japanese, no, zero Japanese knowledge, right? Now there's a big confusion. These two needs to discuss with each other how to perform this discussion. We need a translator. We need a translator to perform this operation. That's why the translation jobs are there. But nowadays, again, the computer is going to conquer the translator's job. Yeah, obviously, computer word is always trying to solve a problem, simply automating for the most part. So simply we take this translator could able to understand both, that means Japanese as well as single language. That's the skill of this translator, to understand both languages well. Now, then simply this Japanese guy tell everything in Japanese language. The translator would translate it into singular language. And again, if there's something required by the singular person, then singular person could be able to translate, ask from the translator to translate it to Japanese language. Then the Japanese person can understand what is there. This is the whole story of the translation. It's just language translation. Why don't we use this exact same method to let this dumb device to perform the operations? That means, why don't we take heavy programming codes, which is written in natural language, to convert into a place that can understand ones and zeros. So simply we can use a translator, right? We can use a translator because our initial problem was this dumb device would not understand this natural language. Then we can use a translator to translate the whole story, right? Similar to natural language, translating into machine language. The translator performs this operation. So simply, we should know, all right, inside the computer, there should be a translator who translates the natural language into machine language. That's the whole story that we are going to discuss in next couple of, probably half an hour, or probably within half an hour. So that's the whole discussion that I want to give to you. We will start with small discussion, as we discussed mainly. Where is that? We have discussed assemblers, compilers, and interpreters. I'm going to discuss one by one in the next time. So we'll start with assemblers, right? I have a video to share with you as an appetizer. Could you please check whether you can hear the voice or not of this video? Can you hear the voice?
No.
No, sir.
I can only see a white screen.
No, sir, cannot hear that.
Cannot hear. All right. Yeah, probably I faced this issue time back. That's why I just check whether I have enabled everything. Give me a second, I'll leave and I'll join. You don't want to leave, right? I'll just leave and I'll join. Sometimes I have missed to add the room words. For some reason, step to reset. Somehow I think have device settings marks. Somehow that's fine. I think yeah, there might be some issue in my machine. Yeah, this was happened even time back. There's a button to enable. It's not giving me to every time for some reason. Somehow that's fine. Nice. This video is in YouTube actually, so you can watch in any time, right? So it's just a small video. I will tell what she's telling, right? That makes sense. So yeah. Yes, she's going to discuss about the assemblers. So you can see these are assemblers, right? Somehow, I think there's no point to go through this video because you can't hear what she's telling is the stuff that how the translation process of all these assemblers are working. If you go to YouTube, you just go to tutorials point assemblers. Uh, do I need to share the link with you? You can check it later on. It's just 2 minutes or 1 minute, 1.5 minutes or something video. It's giving a small overview what is an assembler and how this assembler works. So you can check it later on and you can come up to an understanding what is this assembler. Right? Somehow we are going to discuss assemblers, one of the key aspect that we are going to discuss. Now, somehow, yeah, oh, it's 10 o'clock. Yeah, thanks for reminding. So we'll take a small break of 15 minutes and we'll come to the scenes again, 10:15. All right. You can take a small break. Don't take a lot of time. Just 10:15. I'm perfectly starting. So don't leave and hang on and we'll do the stuff accordingly. Okay. Meanwhile, if you have any questions, you feel free to add it into the chat. I can help you. All right. I think everyone is back to their seats. So ask your guys to join quickly. Some of you are not in the session. So I'm going to discuss the rest of the things now. Right, assemblers. Now we'll start our discussion with the assemblers and why these assemblers are working and how these assemblers job role under our context. It's a program for converting instructions written in low-level symbolic language code into machine code. So assemblers are mainly focused on a specific task. That specific task is to providing a conversion process or the converting the instructions written in low-level symbolic language. So I think we have gone through some of the things few weeks back, even some of symbolic language things and symbolic codes. Somehow these assemblers are mainly focusing on this translation process. It's a conversion of instructions written in low level. Now you know what is low level symbolic language design. What you know is machine code now. Low level symbolic language is a code that is near similar to machine code. Now you should understand a bit more. Low level symbolic language is near similar to a machine code. Once considered one layer more, the first generation computer programmers done their job using binary numbers. So it's a big deal, right? There is a second generation computers born, right? So symbolic languages are much easier for the second generation people because it makes sense for them. But for us, it's a big deal, right? So everyone will agree for that statement. Assembly languages are more powerful than they are, and there is a requirement to convert the assembly language to machine language. Now, assembly languages are really powerful, but what we need to do is we need to convert this assembly language to machine language. That's the core concept. That's the main aspect that we need to understand. Assemblies are powerful, yeah, but we need to convert the assembly languages into machine languages. That's the main job for the assemblers. While involved with the registers, memory addresses, and so forth, because the assemblers are focusing on the translation process. For this translation process, it requires number of registers, which is providing a lot of services for us. It might be general purpose registers, it might be specified registers, which is focusing for assemblers only. There might be. And memory addressing, you know what is this memory addressing map, and I have discussed in detail how these memory maps are working and how these things are connected, the different memory locations and so forth a few weeks back. So you know what are these memory addresses and stuff well. An example is x64 assembly language. If you just search it, you can see some of assembly language things in here. We'll quickly go to the let me share my screen. Yeah. So it's a machine specific languages. So you could able to see this I have searched in here, right? And some of discussions are here. And even Udemy courses are there for cybersecurity people. Now you should be able to understand, oh my God, it's very important for us. cybersecurity guys, you should understand in detail all of these things, because in future it might be comes to you. So this document provides a comprehensive discussion related to the work. At the beginning, they are telling it's not a dead language at all, right? It's not a dead language at all, and some of other aspects also. You can understand what is assembly language and what are the things, right? Assembly language is a low-level language that provides the basic instructional interface to computer processor. That's the stuff that we discussed up to now. You already know. And this book is it's just a simple PDF, but consists of bit hard, 300 about 350 about language pages are there. So they are telling all of these things to discuss well, right? So for the most part, they are telling each and everything to understand. Apart from that, if you go to YouTube, probably we can see we can see, I think this, even last time I have recommended to the students to go through this tutorial from Free Code Camp. He provides like how to perform many things, right? So implementation tasks, like how to set up the environment, right? So personally we have, right? So working with this, how to implement, install the stuff that we want to do and how to code it. So I would strongly encourage, if you have time, it's not mandatory, it's not our scope at all, but if you are really interested, this is a good point to understand in detail. If you can go through these two additional references, that might make sense for you. So you can go through, just search it and you can see it's from Free Code Camp. I would highly recommend you to go through for a good understanding. If you are really interested, you can go through it and get a detailed understanding how it happens in here and there, especially for the security guys. I would strongly encourage you to go through. Give me a second, guys. It, sorry for the small disturbance. Now you can, yeah, the same document that I have shared with you. for the reference if you want. You can go. Right. Assembly language or simple like machine codes. Again, I'm not specifying the stuff that I'm speaking in here would be exactly 100%, 100 out of 100 fit for the course, but there are arguments, right? So if you why I'm telling it again and again, because some of documentation, especially some of, if you take 3 different books, 3 different authors would discuss in 3 different aspects that might be common, because we can't specify exactly what is there, because some of areas are gray areas. That's the root cause. Now we'll see this discussion a bit more in detail. So, it's difficult to write programs in ones and zeros. It's a big work for us. So it's impossible, or we can state it's like really hard to do. So we have to use some another easy thing, which is assembly language. I'm speaking nearly half a century back, right? Nearly half a century back, or back more even. So we have to use assembly languages. That's the most easiest thing to perform this operation. Every processor has its own assembly language. So that's the understanding you should have. Because assemblers are focusing on a processor, as I told from the beginning onwards, it's specified to do some work. Every assembly language is designed for exactly one specific computer architecture. Now, these are the confusions that students are getting. What's the difference in between a computer architecture and what is this x86 and what is this ARM and why these versions are different, right? That's why I told this is very broad area. I can't specify. This is the exact answer, right? It's a very broad area. If we go on for a detailed discussion, it might be take around, I think, more than 12 to 15 hours of detailed discussion is there to understand whole story. But in high level, you don't want to understand in detail because it's not your scope. Your scope is just to understand in high level what happens in here and there. That's the ultimate goal that you need to learn. And specifically, this is generally known as low-level programming languages. That's I told a few times what happens in this case. Assembly language can directly translate, that's the key term, the directly translation process into machine code. Now, it's a big advantage, isn't it? It's a big advantage. We don't want to bother. We just want to write a code and we just want to compile it. Sorry, we just want to assemble it. And assembly means it's directly translating into machine code. Machine code is understandable to the computer. So simply we can write a code, then there's an assembler. This assembler directly converts into machine code. It's a big advantage, and it's a heavy work done by the assembler. So assembly languages are very good in that aspect because the direct translation process. So it equals to machine code. It's more readable. Yeah. So what is an assembly language? A question for you. Everyone can answer in the chat box quickly. Small icebreaker. What is an assembly language? I can see only few of students are engaging. I would strongly encourage everyone to engage with the session. I got 3 answers. Yeah, there's one is typing at the moment. How about the others? All right, thank you. I got 4 answers from the students. Very first answer is direct answer, low level language. Yeah. Okay, low level languages would like assembly languages, but in the other way, we can't simply state it's like 100% accurate, right? So the low level languages could be an assembly, but assemblers are mainly not only the language, low level languages, but there are a lot of other things also. But answer is very good. Appreciate your effort. Next one. Low level language is used to communicate with the computer. We'll take it a bit more advanced. Directly translation process, or it could be directly translate with the using an assembler, right? To understandable to the processor. Will take rather than just a computer, we specify to the processor. That makes sense. We'll go to the next one. Assembly language is a low-level programming language. Yeah, now I have discussed what are the things that you need to understand. Software called assembler to convert into machine code. Yeah, well, that makes sense. And there's another answer. Assembler converts low-level programming language into machine language. Yeah, again, that covers the aspects that we need to know. Right. Thanks for the engagement. I can see 4 answers. Somehow others also, it would be great if you can join for the discussions. Now, each instruction is given 3 or 4 character Mnemonics English abbreviations. As an example, INP, HLT, STA, LDA. Now, all of these things are much shrinked versions, or they have selected a detailed words into specifically 2 or 3 characters. That's it. So these things can be understand. Right? These things can be understand. Easy, right? We can understand. STOR is store, all right. Store accumulator, STA a bit more. Then load, right? And different things are there. What if we compare with the current or existing languages that you do usually? What you do if, right? You do if. Again, it's something that we can understand, isn't it? Something we can understand. We'll take int int. IIT int, something we can understand. All of these are again English abbreviations, but the difference in between these things and this thing is the assembler could be able to directly translate all of these instructions to the machine code. But these things, whatever the stuff that we use in high-level languages, could not directly transfer into the processor, or could not translate into machine codes. A processor understandable code. That's the difference. But you could ever see if we compare in high level, they use mnemonics and we also use in some English terms. Right? So we also use the extraction, but the differences are there. You should understand, all right, there are some differences. So I have mentioned few of these things, INP and stuff, but there are a lot of binary opcodes to the processor to understand. If you have time, I would strongly encourage you to go through a bit more and get some detailed things. But again, having a basic understanding is the objective of this course. It's not required to understand heavily or very detailed under this scope, because this is a first year subject. Currently involved into specific instructions for assemblies such as air conditioners. Yeah, we have some embedded systems still using, but very rare, because it conquered by IoT devices, it conquered by sensors, it conquered by number of electrical devices. Rather just programming, it might be easy to have simple things. Even nowadays, AI integrated components are there. So we are far beyond this discussion. This is a sample of assembly language in Motorola MC680000 and assembled from, right? So you can see it's just like a program. It's like a program that you have written in Java, C#, or Python, or any other thing. There are a set of instructions and there are some mnemonics, right? What to do, what to do, what to do, right? Jump, what to do. And some of instructions are here, right? That's it. We can understand these things easily, yeah. And computer would be able to translate it in an easier manner, sorry. Computer would be able to translate it in easier manner using assembler. This is an assembly code. This assembly code easily translate to machine code using assemblers. That's the whole story you should understand. Now here, well, we got a whole story of this discussion. We'll go back what human can understand and what a processor can understand. This is a machine code. This is a natural language code that we are using. And where the assembly language sits in here before the instructions are coded. Now, assembly languages would be able to provide thousands of instructions. Then these instructions can be translated to the processor. Right? This is the place that assemblers are sitting. Binary code interpreted by the CPU to perform the action, because instructions, we have done it, instructions could be able to translate it in easier manner. Right? We could do it easier. So that's the whole understanding should be. And we'll take a simple assembly code, an example of an assembly code, opcode and operand. Right? Don't worry with this technical jargon. For the first time, sometimes it might be a bit heavy word, but if you have gone through the sessions, the lectures conducted by Dr. Ganesh, and if you have gone through some additional references, I'm pretty sure this is not a big deal. It's quite easy to understand. But if this is the first time, if you are fresh for this subject, it might be a bit hard to understand, like few of these things, but not really hard like last few weeks we have faced. And don't worry, you don't want to go very detailed in this scope. This is a simple assembly code. This is opcode. Opcode means instructions that is executed by the CPU. There's an opcode, specific opcode in everywhere. And there might be operands, the assembly code statement. We have seen some of operands in here, and we have seen the opcodes also. Operand is the data or memory location used to execute that instruction, written in hexadecimal notation. Now, I can remember your batch or someone asked where we are learning, why we are learning this hexadecimal, and is there any purpose? Now you can see, yeah, there's a purpose, because these instructions are written in hexadecimal notation. So we should be able to understand where it actually located. As an example, like I will give a bad example you to understand. If you go through a Java program, you just create a class and just check the reference variable. then you would be able to see 0x location, the memory location of that object created. I'm speaking a bit advanced thing. If this is not your scope, just someone who really interested, right? Some additional information. 0x. So those are the memory locations that you can directly find if you are using like Eclipse MAT memory access tool. You can find many of the things. I'm just giving some additional information you to learn if you're really interested. You just download the MAT tool in Eclipse, memory access tool. Then you can find the memory maps and other stuff in detail. Right, so you can at that time you can realize all of these memory locations are defined in hexadecimal. So some additional information given to you. Don't get upset if it is a bit hard, ignore it. But later on you'll realize what is that. Right, some of originally assembly language stuff and some opcodes and operands are given in here. So you can see it's input and it's given. This is the original assembly language code that we have written, INP. So don't get upset. I'm going to this one in here, this one in here, this one in here, right? This is something that given as a reference, right? This is the actual story that you need to understand the opcode and the operand. I just added the originally assembly language in here to make sure you are understanding what happens in here. Especially you can read assembly language and understand what is an opcode and what is an operand. Basically, this original assembly language provides a opcode INP, and there's a specific description, input value, and stored in the accumulator. And again, the second statement, this statement is STA2A. I have divided it into two parts. That the first part is opcode STA, the second part is 2A, and you could able to store the number at the memory address 2A. What is this 2A? This is in hexadecimal, right? This is in hexadecimal. You know now what is the extract location, which is located in the, which is stayed in the memory. You can able to see I have divided this STA2A into two parts, opcode to STA and operand as to STA and 2A. STA for the opcode and operand for the value, right? The memory address in here. This is dynamic. This is dynamic. You can add many things according to the memory address, but these are instructions. Instructions in the sense like commands that we are used, the mnemonics that we have used. Simply like if else conditions, integers and stuff, right? So simply like those things, these are the values you can just map. I'm telling you just to map, but that's not the extract. To understand what kind of a thing to in easier manner, this is kind of a good example to understand what happens in here. And output the result, halt, stop the program. Right? So if you search this LT, you can find some description in here. Halt. You have to do exercise then you have to halt. So I have gone through an overview of an assembly code. Sometimes it might be irrelevant for the modern technology, but understanding what happens behind the scene is very important because we are not application engineers. We are going to do much detailed research and we are going to work on very extensive work with the processors and stuff in future. So it's our responsibility to understand in detail all of these things. So I would strongly encourage you to go through and understand these things well. Right, we learned up to some extent. We have understood why. What is an assembly language? What happens in what is happening in an assembler? Some of example code, opcodes and stuff, right? You have got some understanding in here. Now let us see some of additional things for these assemblers. Once we completing a program in assembly language, once we are writing assembly language, we want to execute it. Simply you just think in Python you have executed a program, Java you have executed a program. Similarly, whatever the stuff that you have written in assembly language also needs to execute. It requires to execute. Then you can find you have to wait a small time. As an example, if you write a big Java program, sometimes you have to wait a couple of seconds. Sometimes it might be milliseconds, sometimes it might be minutes. Few minutes might be there, even for not for Java, Python, R or any other language. This is very common. Similarly, whenever we are writing in assembly language, there is a time that taken by the assembler to convert this process, because we have written in English language using some mnemonics. We need to translate into a machine code. That we want to translate into the machine code. So this translation, we need a small time. This time is known as assembly time. Specifically, we are known as assembly time. And this translation process is known as assembling or assembly. This process is known as assembly or assembly. All right, I think you got the whole story. Any questions? I spoke a lot. Any questions you have to clarify?
So will we be doing this again when we meet as a recap, like like a small revision?
Sorry?
Will we be doing this like this summary of this lesson in the next time we meet as like a recap?
Yeah, sure, we can do.
Okay, so
Any
this
other
session is
things?
recorded, right?
Yeah, it's recorded.
So it'll be uploaded where exactly?
It's uploaded to Panapto. Do you want the link after the uploading?
Yes, please. That would be epic.
Sure, I will share it.
Yeah.
Okay, right. A program that converts assembly program language. Yeah, we know it now well. Each single line of assembly language is directly converting to a single line of machine code. See the story. See the story. Each line of assembly code, assembly language, if you take, this is a single line, right? It's a single line. This converts into an extract machine code. This is a single line. It converts into an extract machine code, extract machine code and extract machine code. Simply, if we have 1,000 machine assembly code, we have 1,000 machine codes again, plus something more, obviously, right? So, sorry, but something more, obviously. That's the whole story of this machine code of the translation, because we want to work with the assembly and we want to convert it into machine codes. So the assemblers are giving the maximum help for us to perform this kind of operation. And here you can see the assembly language and machine language, but assemblers would not work as it is. We want linkers. I'm going to discuss this linkers later on, like after the last topic. I'm going to discuss the linkers because I am planning to discuss something more and come to this linkers at the last. Somehow, I'm pretty sure you got this whole story now. These are the assembly language codes, and these language codes written by a programmer, and these was translated into machine language, and these machine language things, these bit codes would understandable by the processor. The whole magic was conducted by assembler plus linker plus nowadays there are more and more sophisticated things. If you research, the new things are very extensively enhanced, but you know, up for our level, we don't want to bother for that kind of extreme points. In high level, if you have very high level experience, very high level understand, that's more than enough. If you are really interesting on this, there's a video called Assembly Language and Computer Architecture in YouTube. Again, introduction to x86 assembly language. A series of videos are there. If you are really interested, I would strongly encourage you to go through with these two links. If you want, I can share the links in the chat. Yeah, well, I will share those things with you in the chat. That makes sense if you are really interested. These are additional tasks. These are not required to understand the whole story, but it's good to understand. As an example, for the first video, that's a lecture by one of professor, I can't remember the name, from MIT, 2018, if I'm not mistaken. That video was, but still, it's like, but still in the sense, it's very important for you to understand. He's discussing in very detailed some of points, and it's a good experience you guys to understand in detail. Specifically, this lecture covered most of the things, and I would strongly encourage you to go through and get some understanding. That makes a good learning experience for you. Next, we are going to discuss about compiler. Now, again, sorry, there's a video for compiler, and she's going to discuss about compiler. So basically, it's a system software, right? So you can see. So basically, it's an executable program, right? So right. I'm not spending time for this video because since you can't hear what she's telling, again, this video is in YouTube. If you go to tutorials point, compiler, then you can go through. It's not a lengthy video, again, probably 1 or 2 minutes of video. She's like summarizing everything in quicker manner. I think that makes very interesting. That 2 minutes is more than enough to understand the whole story for a beginner. But you know, some of students might need more time, but it depends. Like some of students would is more than enough to understand the whole story by these 2 minutes. Probably less than 5 minutes. I can't remember the exact time. Less than 5 minutes. Now come, we'll discuss compiler. Have you, like, there are a few Java developers in this class, if I'm not mistaken. At that time, you have learned this word, compilation process. Compiler, Java compiler. Can someone explain what is this compiler? You don't want to go through the entire process. If you have learned this Java language, I'm pretty sure every place we are starting to teach, especially for Java, we are starting the compilation process is explaining to the students how this compilation process is going on. So I'm not expecting that kind of a detailed answer, but in very high level, can someone give an answer? What is a compiler? You can take Java as an example language. All right. If you don't have any idea nowadays, we'll go through the discussion and we'll understand what happens in there. A compiler is a primarily used for programs that translates source code from high-level programming language, autoencoders, to a machine-level code object code. to create an executable program. Now, assemblers are doing work for assembly languages. It directly translates to assembly languages, assembly code into machine code. But once it comes to compilers, we are unable to perform that kind of a simple operation. We can't perform that kind of a simple operation because high level languages do not directly translate into machine level. But these compilers are supposed to help us by performing multiple operations. Then it translates into machine codes. All you need to understand is whatever the stuff that we have wrote in here, class A public static void main string args system.out.println and yeah, curly brackets, that's all for the Java program. Then next, there's a compilation process. There's a compilation process. Simply, there's a compilation process. After that only, we are getting some additional value from that. I will show you after like next slide how the Java compilation process works, but we'll go to a bit more and we'll understand a bit more. Then we'll go to the example. If any error found in by the compiler, then it will immediately update the developer with the technical conflict. As an example, think some of letter you haven't wrote in proper case. If it is capital thing, you have written in simple or simple letters you have written in capital. There might be, right? As an example, class. You have written capital C or simple C incorrectly, or CL, capital class, CLA, right? So it's a big mistake that you have done. At that time, the compiler would emphasize, oh, you have done some error, so you are unable to perform any other operation beyond this. You have to fix this issue immediately. Because compiler knows what to do. Beforehand, before it translates into the machine code, beforehand it knows, all right, this person is doing something else than the rules defined by myself. These rules are defined by compiler, right? Compiler told you have to adhere all of these things, XYZ things, all the rules are regulations. You can't perform any other thing than that. Clear? Right. Now we'll take this process a bit more. What happens inside a compiler, there's a high level language which is written in any high level programming language, and there's a compiler. This compiler would translate into low level language most of the time. That's why I told there's no specific operation to convert into machine language. There's no specific operation to understand a machine language. It's a compilation process. It's mainly focusing on conversion to a low level language. If there's any error while you're compiling the code, you might get into a compilation error. You might get into a compilation error. At that time, the program halt the process, then it allows, no, you can't go beyond this. That's it, very limited. That's the whole story of this compiler. Let me go to a browser and we will see what happens in a sample situation of Java compilation process. I will share a link with you again if you are really interested, or else I will take an image that makes sense. Right, I just search Java compilation process. Now you could able to see this simple process. This is very complex work, but in very high level, they have covered some of aspects. Initially, you are writing the program in English language or any other language compatible with Java. In this case, we are using Java. So what happens in here, there's a source code, a program written in Java language. Then this Java language is translated by the compiler to a bytecode. Then this bytecode could be work in many places without any problem. This is in very high level. In very high level, this is the compilation process. But compilation process is not the it's not the only process. There's a compilation time and there's an execution time or runtime. Right? Two environments in Java, compilation time and the runtime. We have different experiences for these two and different expectations from these two. But in very high level, this is the story of compilation process. Any questions up to now? There are a lot of examples, but for the most part, everyone is speaking the same thing again and again. Not really. These are a bit complex work. Any questions up to now? Everything is good to go. Confusions, hard things to understand, or very easy to understand. Sometimes today it might be really, really easy to understand. What is the story? Any questions? No questions. All right. Then the next one is the interpreter. Again, there's a small video, probably not take a lot of time, but I'm not going to play this one because no point at all to this one. Right. So an interpreter is a computer program that directly executes instructions written in programming language or scripting language. Here, now this interpretation is right. It's interpreting. It's interpreting. Interpreter is a computer program. Again, it's a computer program that directly executes the instructions written in a programming or scripting language. For the most part, scripting languages are not programming languages for the most part, but there's a strong relationship in between these two, but I'm not going to discuss all of these things at the moment. You might learn all of these things in future. Okay, and scripting languages are much towards interpreters, much towards. It's just very high level sentence. It's not 100% accurate unless you might come up with number of arguments in this language, what you can do, what you can tell, and this language, what you can tell. So interpreters are there, mainly focusing like compilers, but the process is different. there's no compilation process. The difference is there's no compilation process. For the compilers, there's a compilation process to get into the work done or convert it to the machine codes. But in this case, the interpreters, we don't want to perform that kind of operation. That's the difference. Without requiring them previously to have been compiled into a machine language program. So you can state at the moment, sometimes you might think, oh my God, interpreters are much easy, then why people are going for compilers? Sometimes that question in your head. Yeah, obviously, good question. You just research, and I would strongly encourage if you can find a proper answer for these kinds of things. From my perspective, from my view, for me, both interpreted languages and compiled languages are good. Why? Based on the problem that I'm going to solve and based on the resources that I have to utilize. For you, since you are a beginner, you might have different answers. I agree with your answers because you are dealing with the scope of knowledge that you have. But after a while, once your knowledge is expanded, your answers might be a bit different. For now, yeah, I have to agree for your most of the answers because internet provides a limited scope, right? Some of articles are very limited scope. That's not bad, that's the reality. Python, MATLAB, Ruby are some of program languages used and interpreted. So for the most part, again, interpreted languages. Shall we do a small activity as an icebreaker? No need, right? We don't have much time, probably. Yes, we don't have much time. We have very limited time. So nowadays, somehow it's like basically working with the work that we have learned. These languages, interpreted languages. Now you have to understand there are compiled languages and there are interpreted languages. Not for now, but for later on, if you are learning in here in this institute, we are going to discuss the same thing in detail in future, the programming languages and paradigms. In that language, we are going to discuss in detail the differences and why we are applying these interpreted languages, why we are applying these compiled languages, how these compiled languages and interpreted languages are working, and so on and so forth. So basically, it's like very complex question. It's a research question. Probably if you are in here, you might learn that things in near future, not far away. Next couple of years, you might learn in detail. But as a heads up, I would strongly encourage you to go through and research it now. Then probably you don't want to bother in future, since you have a lot of time in nowadays. Right. And some of extra learning, I would like to give some additional resource for you to learn if you are really interested. This document covers, this web page actually covers for the most part many aspects that we have discussed during the lesson. I will share the link in the chat so you can go through. This is a very common site, Geeks for Geeks, everyone knows. So you can learn a lot. And again, something else I'm going to discuss. This is not our scope, but some additional scope for you, additional thing, transpilers, source to source compilers. So basically what a transpiler involves with legacy to stable versions. For the most part, we have some of major changes in code bases. Whenever if we have a major changes, we have to use new syntax for the old syntax. So we want to change whole story again. As an example, Python 2 to Python 3. It's a whole new thing. If I'm not mistaken, Angular also done the same thing. If I'm not mistaken, I can't 100% tell, but I can remember Angular uses this kind of thing. So at that time, we have to use a source-to-source compiler, or simply we have to use a transpiler in that case. It's some additional knowledge for you. And I found some interesting video in YouTube, which is helping to understand the whole story of comparing this C with the code and C language stuff. I have shared it in the chat. I would strongly encourage you to go through and understand these things. These are additional resources, guys. If you are a bit feel hard, no worries at all. You just ignore it. That's totally up to you. We have covered the second component of this subject, and we know language translators. Initially, we have discussed programming languages, basically high level and low level languages. Then we have discussed how the translation process happens using what we call these translators, language translators. Then we are going to discuss the last aspect, that is constructs, how these programming concepts are grown. I'm not going to in detail of these things because it's much towards for covered by your programming lecturer, right? But for the sake of understanding in high level what we have done and how it applies, I'm going to discuss just a few things, simple if condition and a loop. So in this case, you could be able to see there's a starting point and there's a if condition. This is a flow chart. And if the condition is true, then body would execute, then statement just below the if, then it's finished. In any case, this condition is false. If there's a nested if condition, if the nested condition is true, then again nested if body comes in here and it goes. What is a nested if? That's like if and there's a condition in here, condition inside here, condition, and inside that scope there is another if inside if, and there's a specific work to do, and this is a nested if. This is nested if, and this condition, if condition false, then as body it goes end, then it ends. In very high level, that's the whole story of if condition. Similar, the next one I would like to state is the while loop and the do while loop. While loop starts here. I started here. Start, then condition is true or false. If it is true, do the task till the condition false. If the condition is false, it's going to be ended. If you have any programming experience, regardless of the language, it might be Java, Python, or any other language, these are very common. But once it comes to do while, you don't have do while in every language. Do while allows us to do a task before checking the condition. That means at least once the task would execute. In this case, if the condition is false, that's it. Nothing would happen. As an example, at the initial point, condition false, then task is not performing in any given time. But under the do while loop, there's a task which is executing at least once, then only the condition is checked. That's the main difference in between do while and while loops. Overall understanding is more than enough. All right, this is if, this is do while, this is while, because you are not supposed to learn all of these things during this lecture, but your computer programming lecturer would cover the rest of the things for you. Another programming construct is stacks. Again, this is not programming. These are data structures and algorithms. Probably that lecturer would cover the entire story. You will learn different data structures. You will learn different algorithms where it applies for different cases. Somehow, in simple terms, stacks are just set of pile of anything. Think in this case a pile of papers, right? Similar to this, we can store the data. We can store the data in a computer. So what happens in here? We can store the data in a computer. We can store the instructions in a computer like a stack. You got the story? What's a stack? Any questions? Sorry, any questions? I think you got these basic programming constructs, if else and nested if else and while, do while. Any questions? All right. In simple terms, see plates in real world plates. We kept all the plates in here like a stack. So this is the element that you can take at the beginning. But is this the first element that you kept in this set of plates? Yes or no? 2 marks. No. No. What is the first plate that we have kept is the last one. Isn't it? This is the last plate is the first we have kept. But if we want to take it out, last kept element is the going first. So simply we have a data structure for this one. So stacks are abstract data type. These are not fully implemented. So just in high level data structures, right? And what's a stack? Yeah, we know. We'll get an example of this behavior for this stack. We have major 2 things. One is push and the other one is pop. What happens in push? Push means a fancy word to add an element to the stack. Simply in this case, we are adding a plate here on top of this one. That's it. Right. So push operations work like this. This is the initial element, the first element. Then there's another element. So what we need to do is we need to keep on top of that element. So this is the first element and this is the second element. Similarly, we can keep the rest of the elements any amount 1, 2, 3, 4 and any amount up to the. So you all need to understand push means adding an element to the stack where we are going to add to the top. Yeah, we are going to that. We are going to add it to the top. Next, what we are going to do, we are going to discuss pop, remove, and element. So this is the element. Sorry. This is the structure that we have. How we can remove an element. We can remove this element at the beginning. Right. So we can take it out. That is pop operation. So after the first pop operation, first element is gone. Now, sorry, what was going on? Now this is the only stack that we received. The next pop operation would remove the next one. After removing the remaining is the last element. Even if you want, we can delete. That means the stack is empty. I have given in very high level what's a stack, what's a push operation, what's pop operation, and how these are work. There's a structure called last in first out, LIFO. Last in first out, stack behaves like that. Last in first out. Right. This is the story that why we learn these stacks, because we have to understand there's a stack pointer on top of that stack, because this is the place that instructions are on top of. Whenever the recent instructions comes, it's in the top. So recent instruction would read by the rest of the things. Don't bother a lot for this stack pointer, but I would strongly encourage you to spend few hours probably to understand this stack pointer. Probably not a lot, just 1.5 to 2 hours is more than enough to understand what is this stack pointer in detail. But if you just want to get some basic understanding, it's just 5 to 10 minutes is more than enough to understand the stack pointer. But again, you don't want to go in detail. That's out of our subject scope. So, sorry, again, I have added a small video to combine for the most part what happens in here and there. Right. So, sorry, the seamless linkers and stuff, but there's no major issue if you don't know the whole story. I will, as Ahmed, if I'm not mistaken, requested, I will quickly go through it next week also with the videos also, including videos. Not a lot. It might not take more than 10 minutes for the discussion because we have to discuss the next topic also. But in very high level, I will go through a quick recap in next week also. Next week is the holiday. Yes, next week is holiday. And so January, so next year we are going to discuss that one again. The small recap would happens at that time. All right, I will quickly go through what happens in a link. This is the last element that we need to discuss for the today discussion. What happens in a linker, it's not a big deal. Linker is just a place to provide a linkage of all of these modules. Right? As an example, we wrote different classes. You just think like this. This is not the exact same thing, but to understand, but to interpret to someone else, you just understand, all right, this kind of a thing happens in here because we can't jump or we can't deep dive and take the real experience. But to get some real experience, we can create some prototypes, right? So kind of a prototype kind of learning that we have to do. So think these are different Java classes or C# classes that we have developed in here. Then we have linked together using a small program called linker. Then the linker would links all of these things. As an example, think there's a print statement or something that requires some additional package. Then it can compile, it can take all of these things that required to do. Then it connects together. Then finally we can get an executable program. That's the whole story that you need to understand. In very high level, I know it's very high level that is going on, but it's more than enough to understand that kind of a thing. But if you have time, no worries at all, you can go through. There's a revision. Would you do this revision or not? Do you like to do it or not? We'll finish it. What we can do is I'll finish the work, right? Then you can spend a couple of minutes to do this revision task. Then you can leave if you want. Right. I will because this is something that done time back. And for more advanced discussions, you can go through a separate course by MIT OpenCourseware. So it's again and again, I'm telling, this is bit advanced. You do not supposed to go to that detailed understanding at all. But if you are really interested to deep dive, I would strongly encourage you to complete this course. I will share the link with you. This is giving, if you have time and if you are really interested. If you don't have time, if you are not interested, no need at all. Right? No need at all to work on these things. Right. That's all I have today to give. And there's a small homework that it's available in the course page. You feel free to go through the course page and please make sure to do the answers. I got few answers, you know, I'm not reading, like I'm not going through one by one, but in high level, I just skim it and I just give it some comments for some students, but I got only one student. Yeah, for your batch, yeah, just one student said some homework related stuff. Others, sometimes you are really bothered to send. Don't worry, you just send it. If there's some modifications are required, I'll definitely update you. What are the missing pieces and stuff? It's yours. It's your responsibility to complete these homeworks just for you. And these are just for you, not for someone else. So, right. Last but not least, any questions?
So I have a question.
Yeah, please.
So when is the portfolio's markings gonna be released?
Sorry.
The portfolio thing we did, the CPU process.
Yeah.
When will that be released, sir, the marks?
Within 2 weeks of time, probably. Sometimes January 10th, 15th around. Why?
No, sir, the anxiety is killing me.
Huh?
I want to know how much I scored, sir, because I'm not sure if I did it right.
Ah, nowadays. Usually my experience is that that's just very small portion, right? 10% or something.
Yeah, it is 10.
Yeah, 10%. For the yeah, last few years, my experience is most of the students scored around 4, 5, 6. Extremely, some students go on for 8, 9. Rarely, very rarely. That's okay. For marking is for that one is not a problem, but the next one onwards, I'm pretty sure you will do a very good job and you'll score very well. So uh, that's my experience, right? So don't worry.
Thank you, sir.
Don't worry with the marks. Worry with the skill, or as I'm always telling. Right. Any other questions? No questions. I want to get your input, quick input. There's a small question. It's an anonymous question. Quickly give your ratings.
So what?
I have
Rating.
shared a link in the chat. It's anonymous again. Don't worry. I just want to check. Are you happy or not? As usually, I know you are really happy with this lecture series.
How
But I
about
want to
today's
get.
session, sir? I'm rating
Yeah.
it 1.
Yes. It depends. It depends on how you can give anything. I don't get upset. I just want to get your input. That's it.
Just kidding, sir. Just kidding. I put 5.
Yeah, I know. Nice. All right, guys. Yeah, Sharon, any questions?
Can't we do this online?
Sorry?
Can't we do our lectures online for the next weeks as well?
Yes, it's really great online.
So life is
See,
easy
this
this
is
way, sir.
like a lifesaver. Online thing is a
Yeah.
lifesaver.
Yes, it's easy to understand also.
Really?
So
Yeah,
by the
because
way, do you feel like online or physical is easier? Which one do you feel like?
I don't care whether it's online or physical. But you know, the comments from the students are like my online lectures are very good. And it's very clear for the students. That's that's the usual comment.
So shall we
Yeah.
take this to the ACBT administration and tell specifically
No,
for this
no,
subject, computer
no,
fundamentals, we are
no,
loving the online
expect.
sessions?
No need, no need. Don't worry, don't worry. We don't have any opportunity to do online classes. I'm really sorry.
Sad,
You don't want to
sad.
request it. Right. Don't request it. We have to do it physically. But don't worry. The next couple of weeks, next couple of lessons like this, similar to this one, it might be much easier. Don't worry, right? And
So
we can grab the most of the things.
the best part of online is I was on my bed the entire time, sir.
It depends.
The best, sir.
Yeah, it depends. It depends. It depends.
So I'm
Right.
pretty sure you are as well. Like, don't lie. No camera on.
Yeah. Okay. Somehow that's fun.
Easy
All right.
lives.
All right, guys. Yeah, that's it for today. And Happy New Year as well as any Christmas, guys. I need Christmas cake in the next session. Any Christmas?
Happy New Year, sir.
Happy New Year, not
And
Christmas, all
have
right.
a Merry Christmas, sir.
No Christmas for me at least.
So no,
All
no,
right,
you
guys,
have
then.
it, sir. You have it. Of course you have.
Shan, yes, what's the question?
No, I was going to say Happy Christmas, and it is more sort of like a Ramadan holidays that we are going to get Watlap funds and all.
So he
Yeah, we
already
have
booked
a lot
one,
of
sir.
Muslims there.
So you, Afka and Shasni, get ready.
So he has already booked a Vatlapam for him.
No, we are getting some copies for New Year.
I'm
After,
I'm coming after you people in that same time.
we are,
So
we are
get
getting
ready.
so
early.
many things. Even for the New Year,
Or-
we are getting.
All right, guys. Okay, so I need to leave the today's session. So if you feel, if you have any questions, you feel free to drop an email so I could able to help you as much as I can, and start your assignment earliest as possible with your colleagues. Don't go for conflicts. Every time I got at least one conflict from one team. So I would strongly encourage there's no conflicts in this time. And you people are connected in the physical environment, probably that might be solved almost every problem. So I would strongly encourage you to do start work and do the rest of the things. All right, then, see you, bye bye, happy new
Yeah,
year.
thank you,
We'll meet
sir.
in next year.
Thank you, sir. Happy New Year. Bye.
Sir, Happy
Thank
New
you,
Year.
sir. Happy New Year.
Adam, any questions? Adam?